Let's talk about solving a linear equation in one variable. When we solve an equation, we're looking for the number that makes the statement true for our equation. For instance, for the equation here, x plus 2 equals 5, we're saying what number, if you add 2, will give you 5. You're good enough with arithmetic that you know that the answer is going to be 3. But sometimes the problems get a little bit harder, and when they do, we need a process that we can follow so that we'll know how to get to the correct solution. What we want to do is to try to isolate the variable. That means to get it on one side of the equation by itself. In order to do this, we're going to undo anything that has happened to the variable. For the problem that we're looking at, what's happened with the variable is we've added a 2. So to undo that adding, we need to subtract. Now, anything that you do to one side of an equation, you have to do to both sides of the equation, or you've changed what the problem was. So since we've subtracted 2 here, we also will need to subtract 2 over here. Now, on the left-hand side of our equation, these numbers are what are called additive inverses. That means if you add them together, the result is 0. So these 2's go away, and we're left with just an x isolated on one side by itself. On the other side, 5 minus 2, that's the 3 that we expected. Now, if we want to know if this is truly a solution, we can check this answer by taking it and putting it in the original equation to see if it's a true statement. If we put 3 in for x, 3 plus 2 is 5, so this answer is correct. Sometimes you'll be asked to write your answer as a solution set. Your answer blank may look like this with what are called set braces inside the answer box. All we've got to do is take the solution that we've got and put it within those braces to complete this answer. It is okay for one thing to be a set. A set can have any number of members in it. It could have no members, 1 member, 2 members, or a lot of members. An infinite number of things could be part of a set. For this one, the solution set was just 3, since that's what made a true statement. Let's look at a little bit harder equation for us to solve. This one's got a few more things for us to do. As we try to isolate the variable, undoing the things that have happened to it, we want to undo in reverse order from order of operations. So the first thing that I'm going to get rid of is the 1 that has been added. How do I get rid of a 1 that's been added? I'll subtract. And if I've done it on one side, I have to do it on both sides. Now again, these are additive inverses and go away, leaving me 2x on the left and 5 minus 1 is 4 on the right. I didn't want to know what 2x was. I wanted to know what x is going to be. So there's still a little bit more that needs to happen. The 2 and the x are combined by multiplication. To undo multiplication, we divide. If you've divided on this side, you also have to divide on that side to keep the equation in balance. The 2's will divide out, leaving me the x isolated on one side just like I wanted, and 4 divided by 2 gives us 2 as a solution. Again, we can check to see, is this really a solution, by taking the 2 and putting it in. If it gives me a true statement, it's a solution. If it doesn't, then it's not. Put 2 in for x, 2 times 2 made 4, 4 plus 1 is 5, so 2 is a solution for this problem. Now, the steps that we took here as we were trying to undo, if you need those steps, then that certainly is fine. But we can clear out some of the clutter by skipping over some of these things and streamlining our process. The first thing we did here was to subtract 1. We didn't have to put a minus 1 there to know we were going to subtract. You knew you wanted to do the opposite of what was happening here. And if it was done on the left, it had to be done on the right. Here we knew we were dividing by 2. I don't have to put that line with a 2 under it to know that I'm going to be dividing by this coefficient. So if I've done it on the left, it also has to happen on the right, and we don't need the line with the 200 here either. Whatever number is out in front of the variable, divide both sides by it to get to our result. So now how that may look if we had it in an original problem in a streamlined fashion. For instance, the one that is here, 16x minus 8 equals 0. Let's first move the 8 across. This will give me 16x equals positive 8. When I've added 8 to both sides, 0 plus 8 gives me 8. Now the next step is to divide by 16. I don't have to write a line with a 1600. I know I'm dividing both sides by 16. Now we should always reduce fractions as far as we possibly can. 8 over 16, this will reduce to being 1/2. And so for this one, our solution set was 1/2. You could check that one, substituting it back in for the original equation, in for x. 16 times 1/2 would be 8, and 8 minus 8 is 0. Here's another one to solve, but this one's a little bit harder. This time we have variables on both sides of the equation. Remember that our goal was to isolate the variable on one side of the equation. So the first thing I need to do is to get those x's to be together on the same side. It doesn't matter if we go left or right with them, but we need them to be together on the same side. Let's take this minus 3x and let's move it over to the other side. Now, if it's a minus 3x here, as we move it across, it's going to change to being a positive 3x. So really what's happening here is we're about to add 3x to both sides. When I do that, I have 9x minus 4 equals 23. And now this one is gone because we've moved it to the other side. Now it looks like one of the equations that we were working before. So we want to proceed just as we did then. Let's undo the things that have happened to the variable. Adding a 4 to both sides gives me 27. Dividing both sides by 9, the coefficient of the x, gives me x equals 3 for our solution. Just like before, you can take this 3 and put it in for all of the x's in the original equation, and if you've got the same thing on both sides, then that 3 is the correct solution. Let's look at another. On this one, there's a little bit of work that needs to happen before we can begin our solving process. We first need to simplify it and see if we can make it look like the ones that we've already worked. This says take 6 and multiply with the things in parentheses. So let's do that to begin. If we multiply into the parentheses, we'll have 6x plus 24 on the left. And multiplying on the right-hand side, this is 8x minus 16. Now, just as we did in that previous problem, I want to get the x's together on the same side of the equation. It doesn't matter which side you go to. I personally like to keep the variable positive if I can. So knowing that, I'm going to choose to take the 6x and move it to the right so that we end up with a positive x after we've done our subtracting. This 6x was added, so what I'm going to do is to subtract 6x from both sides. It'll make it go away over here. Subtracting a 6x, 8x minus 6x gives me 2x, and let's bring down that 16. Now let's undo the things that have happened to the variable. This minus 16 needs to go. I can get rid of it by adding it to both sides. When I add 16 to 24, that gives me 40 equals 2x. And now let's get rid of the 2 by dividing. So it looks like 20 is our solution. Again, we can check this by taking the 20, substituting it in for the x's in the original problem, and if we have the same thing on each side, then our answer is truly a solution.